The name of Chapter 7 is Polynomials. And the root, or one of these roots in the word, is nom. And so if you think about number, it's like numerical. Nom just means number. And poly means many, so these are made up of many different numbers, many different terms. So in section 7.1, the first thing you're going to do is you are going to multiply monomials. So to start, I'm going to write the definition of a monomial here and show you an example as well. So here is just the definition of monomial, and I had to bleed over into the other space, so I'll erase this in a moment. Go ahead, pause this, and write it down, and now I will explain it. A monomial is a number, so it could just be like a number 4. That's a monomial. It could just be a variable, like x, or a product of a number and a variable. So if I had 4 times x, that works too. And it doesn't have to be just one. It could be a fraction times a variable, times another variable, times even more variables, as long as they're not separated by addition and subtraction or something like that, because those would be multiple terms. These are just single terms. So all of those things I expressed are monomials. Here's what is not a monomial. What is not a monomial is something that ends up with variables in the denominator, because then you're dividing by variables and you're not multiplying by variables. Now that is not okay, but this is what would be one. Just multiplying by a fraction, that's okay, because that's just a number. But it's the variables that matter. I'm going to clear this out and move on to the constants definition. So, monomials that are real numbers, and then, for example, if I just had the number 2, that would be a constant. And the reason it is a constant is because it does not depend on a variable whatsoever. It is unchanging. Another example would be just, whoops, that's the worst 4 ever. That's like a 4. That would be another constant. So label the parts in this monomial. I call it a monomial because it is just one term by itself, and it is not having any other things added onto it. That would not be a monomial. That would be a trinomial, and this is a monomial right here. 2 terms that are review, 1 term that may be new. The review terms are the words base as well as exponent. And at this point, I think that's common enough to where if you see exp only, you'll know that it's an exponent. Now the new word is, if we have the value of a number in front of this variable, that would be the coefficient. So if I had something where I saw y squared, its coefficient would be 1. If I had 10x cubed, its coefficient would be 10. So that value that's out front is called the coefficient. Say that to yourself a couple times to get practice with it. Now, the first thing they want to do in the textbooks is make sure that we understand what a monomial is. So these first directions say, determine whether each expression is a monomial. Explain your reasoning. Well, when I look at this first term, I have P and Q separated by addition, and these are always multiplication only. So for this is not a monomial. So I'd probably rewrite this in the spiral if I'm doing my practice work. So I'll have a semicolon after P plus Q to say, that's not an I, that's supposed to be more of a comma. So it's separated by a semicolon, and then I'm going to say, not a monomial. And if you have the directions above this and you've written that down, it's okay to just say no. And my handwriting's not very clear there, but there's the word for you to write it. And then you can say, it's separated by addition, or you can be like, there are 2 terms that are separate. I think that's clear enough. Now, I think that can make this one over here an OYO problem. I'll put the answer up in just a moment. No 2 terms. So I'm saying no comma, there are 2 terms, not just 1. So let's jump down to 4xy to the 4th. Well, is it separated by addition and subtraction? If there was a fraction out here, that wouldn't matter. like 4/3. And as long as we're not dividing by variables, we're good. So I'm going to say yes. And I guess we could say it has multiplication, but let's just keep it a yes, yes. Multiplication only. And it's a single term if you want to think of it that way. See if you can do this one on your own. Pause it. I'm going to talk through it now. No. Division by a variable. Division by a variable. So that's a no-no when you're dealing with monomials. That would be division and not multiplication for this one. Now, the deal is this. You haven't seen something like this yet, and you'll get more deeply into it, but it looks weird. I'm seeing a negative exponent. Let's just assume no, and then we can say negative exponent. I'm going to talk about that more in a moment, and you'll see what I mean. All right, now, I guess just to show a little separation between this and the next video, we'll stop here. That way these notes will stop on the big picture definitions and what they are before moving into the application problems.